You know, when you put like a single drop of pond water onto a glass slide and just look at it under a microscope, at first it's really nothing.
Right. It's just this blurry, uninteresting dot.
Exactly, just a speck.
Yeah.
But then you adjust the focus, right? You dial in the lens, the light hits it just perfectly, and suddenly that one little drop opens up into this entirely bustling ecosystem.
Oh, yeah. You start seeing organisms moving around, all these complex structures interacting.
Yeah, it's a whole universe hidden inside this tiny, tiny constraint.
It really is a complete shift in perspective because, the boundary of that drop actually holds an immense amount of hidden depth, assuming you take the time to really look closely at it.
And that is exactly the lens we're applying for you on today's deep dive. We are taking a microscopic look at this single, seemingly brief, highly technical blog post.
Which, on the surface, does not look like a universe at all.
Not at all. Our source material today comes from a site called kianmn.org, and it's dated April 11, 2026. At first glance, it is just a quick, incredibly niche note about a programming bug.
Just a tiny speck of water.
Right. But our mission today is to show you how this one isolated post is actually a gateway. It is the entry point into one of the most astonishing multidisciplinary digital gardens on the entire internet.
It's wild. We're going to start with this microscopic line of code.
Yeah.
And we'll zoom out to uncover, like, a 15-year archive of a true modern polymath.
Yeah, a creator who publishes exactly 2 things a day, every single day, without fail, spanning everything from, artificial intelligence to literal aquatic cave design.
It's such a masterclass in how hyper-specific technical problem-solving can reveal this much, much broader worldview. Like, when you examine what this author is doing, it's not just about code, it's about how to structure thought itself.
So let's unpack this drop of water and dive straight into the actual post. The author of the blog, who signs off as Ang, is working at 3:00 p.m. on a post titled Notes on Haskell Programming, Part 106.
Part 106, which is just...
I know. We will definitely get to the sheer volume of his writing later. But the post itself is about refining header parsing by enforcing end-of-line constraints. So, Ang is fine-tuning how a piece of software parses, or reads, book headers, and while adding new test cases, he hits a bug.
We should probably pause for a second to acknowledge what Haskell actually is, because it really contextualizes the whole problem here.
Yeah, please do, because it's not exactly JavaScript.
No, not at all. Haskell isn't an everyday language you use to just throw together a quick, flashy mobile app. It is a purely functional programming language.
Meaning it's very strict.
Extremely strict. It relies on rigorous mathematical logic. In Haskell, you are essentially building a complex system of absolute truths. So when Ang is writing this parsing program, he's dealing with a very, very rigid environment.
And he's specifically tweaking how the program reads frontmatter and backmatter. For anyone who hasn't worked in publishing, frontmatter is all the stuff before the main story of a book starts, like the title page, the table of contents, the introduction.
Right, and backmatter is the stuff at the end, the index, the appendices.
Exactly. So the bug he finds involves this specific string of Chinese text. It's pu'et, and I'm probably mangling the pronunciation, but it basically translates to introduction, this is introduction.
And the program is just completely getting confused by this text. It's incorrectly flagging that specific string as a header when, it should just be recognized as a regular paragraph.
Which totally makes sense if you think about how a machine reads, right? The software sees a keyword like introduction and immediately assumes, oh, I must be looking at the title of a section.
Yeah, it's jumping the gun before analyzing the full context of the line.
So Ang digs into the code to find the fix, and he realizes that the system is missing an end-of-line check. An EOL check, as he writes it. It's missing this check for keywords in the front and back matter.
The mechanism here is honestly brilliant in its simplicity.
To make this relatable for you listening, if you've ever formatted a basic text document, you know this exact pain. Say you want your document's title to be bold and huge. You highlight it, hit the bold button. But if you don't explicitly tell the computer where that title stops...
If you forget to hit enter.
Right. If you don't hit the enter key to create that boundary, you start typing your next sentence, and suddenly your entire first paragraph is trapped in giant bold font.
Because the computer just doesn't know where the title ends and the normal text begins, unless you actually force that boundary. You have to provide the constraint.
And the real so what of this bug fix is what Ang notes after he solves it. He writes that by enforcing this end-of-line requirement, the parsing rules actually become much simpler.
Which seems totally counterintuitive at first, right? You'd think adding a strict rule makes things more complicated.
Exactly, but it actually makes the whole system simpler.
That's the hidden elegance of constraint-based problem solving. We often think of constraints as things that hold us back, things that make systems rigid or frustrating.
Nobody likes rules.
Right. But in complex systems, whether that's software architecture or urban planning or even managing a team, adding a strict boundary radically reduces the complexity of the entire system.
Because the program no longer has to guess.
Exactly. It doesn't have to run these complex probabilistic models or contextual analysis to figure out if introduction is a header or just a sentence. The rule becomes binary. If the keyword doesn't sit alone at the end of the line, it's not a header. Less freedom for the software actually means a more reliable, elegant function.
You know, you don't spend a Tuesday afternoon wrestling with a microscopic end-of-line constraint like that unless you have a very specific disposition.
Oh, absolutely not.
And if you look at the About and Disclaimer sections of his blog, you get a really clear picture of Eng's identity. He describes himself with this very specific, deliberate phrase. He calls himself an old software plumber.
I love that phrase.
Right. An old software plumber who spends his nights tinkering with FLOSS, which stands for Free Libre and Open Source Software.
The word choice there is heavily loaded.
I find it so fascinating because, you know, in the tech world, people usually give themselves these incredibly grandiose titles like, I'm a software architect, or I'm a full-stack engineer, or code ninja.
Yeah, rockstar developer.
Exactly. But plumber sounds so unglamorous. It conjures images of fixing a leaky pipe under a sink. It feels like he might be totally underselling himself for someone writing complex Haskell parsing rules.
Well, adopting the identity of an old software plumber is actually a really profound, deeply pragmatic philosophy. Think about the mechanics of what a plumber actually does.
They fix things that are broken.
Right, but specifically, plumbers deal with flow. They deal with leaks. They manage the hidden infrastructure that sits behind the drywall, right?
Right.
The systems that literally keep civilized society functioning, but that everyone completely ignores until it breaks.
The ninja or the rockstar coder wants to build the flashy, superficial app that everyone sees on their phone screen.
And the architect wants to design the shiny glass skyscraper.
Oh.
But the plumber cares about the unglamorous foundational piping.
And if you look at Eng's support page on the blog, this mindset just perfectly aligns with where he puts his money and his energy. Under his Do Support heading, he specifically lists donations to fundamental internet infrastructure.
It's a really curated list, isn't it?
Very. It's the Electronic Frontier Foundation, the Free Software Foundation, the Software Freedom Conservancy, the Tor Project, and Wikipedia. None of those are tech startups trying to disrupt a commercial market for profit.
No, they are the essential hidden pipes of the free internet. Wikipedia is literally the infrastructure of human knowledge. Tor is the routing infrastructure of privacy.
And the EFF and the FSF are the legal and philosophical infrastructure keeping open source alive.
Exactly. So by calling himself a software plumber, tinkering with open source software, Eng is aligning himself with the maintenance of the whole ecosystem. He cares about the system flowing correctly, cleanly, and freely.
That perfectly explains the satisfaction of fixing a tiny end-of-line constraint in a Haskell program. He's sealing a microscopic leak in a pipe. He's making sure the flow of data is pure.
And, you know, a plumber doesn't just fix one pipe and retire. They maintain the whole network over years.
Yeah.
Which really brings us to the sheer scale of what he's doing on this blog.
The sidebar of his site is just, it reveals that he is running the most active, relentless toolkit imaginable. I want to walk through his publishing history because the numbers are staggering.
They really are.
He starts relatively modest back in 2011, publishing 26 posts. By 2013, he's up to 146 posts. He's building some momentum.
Getting into a rhythm.
Yeah. In 2020, he hits 366 posts, which is a post a day for a leap year. But then you look at recent years, 2022, 730 posts. 2023, 730 posts. 2024, another leap year, 732 posts.
Wow.
2025, 730 posts. That is exactly 2 posts a day, every single day, without fail, for years. And by mid-April 2026, the time of our source material today, he is already at 303 posts for the year.
The output is almost difficult to comprehend when you look at that timeline. It requires an immense amount of discipline.
It defies all modern logic of content creation. Today, everyone is trying to, game the algorithm, trying to go viral, posting at the perfect time of day with the perfect thumbnail.
Yeah, you don't post notes on Haskell Programming Part 106 to get 1 million clicks.
Definitely not. It's less like running a sprint for an audience and more like laying bricks. 2 bricks a day, every day, regardless of the weather, regardless of who is watching. Over 15 years, you don't just build a wall, you build an entire city.
It highlights a really vital concept in modern knowledge work, which is the idea of learning in public. If you examine the project tags in his sidebar, you start to see the actual scaffolding of his mind.
What kind of tags does he use?
He has tags like MOO Notes, which are massive open online courses. He has This Week I Learned. He has Pearl Weekly Challenges, This Month in Review.
He's meticulously documenting every single step of his own education.
Right. The immense value here is in documenting micro-progress. Most people wait until they have totally mastered a subject to write about it. They wait until they have the perfect, polished masterpiece.
Which creates incredible friction. You stare at a blank page and feel overwhelmed by the need to be profound.
Exactly. Aang does the exact opposite. He documents the messy, daily process of iterative learning. He writes down the bug he found at 3 more TM, explains the end-of-line constraint he used to fix it, publishes it, and just moves on.
2 posts a day means you literally cannot be a perfectionist.
You must be a pragmatist. You are forced to synthesize what you learned today, externalize it, and clear your mental workspace for tomorrow. It's this highly disciplined form of cognitive offloading.
And the discipline applies to everything, not just code. This is where the scope of the blog really opens up for me, because it's not just the sheer volume of the posts, it's the variety of the subjects.
The cross-pollination here is incredible to see.
If we isolate and look exclusively at his output from just the first 2 weeks of April 2026, just those 14 days, the same mind that is fixing Haskell end-of-line bugs is deeply invested in the physical world. Listen to these titles from just those 2 weeks.
Let's hear them.
He drops Notes on Gardening, Part 863, where he's detailing hydroponics, the growth of Brazilian spinach, and analyzing the soil quality for white sesame seeds.
Wow.
Then he drops Notes on Fish Keeping, Part 231, where he is writing about breeding a specific fish called a pistogramma, evaluating water parameters, and designing literal aquatic cave designs for the fish to breed in. He also publishes Notes on Dieting, Part 111, tracking his daily body weight, and Notes on Exercises, Part 18.
It paints a picture of a remarkably engaged mind, interacting with vastly different domains.
And it isn't just a fractured attention span. I'm looking at his coding tags from this exact same period: Elixir, Erlang, Rust, Python, and Go.
Those are entirely different programming paradigms.
Right. Rust is known for intense memory safety. Erlang is designed for massive, fault-tolerant concurrent systems. Python is the king of quick scripting and AI. Go is built for scalable web servers. He isn't just learning one syntax, he's collecting entirely different tool sets for solving problems.
And then he's tracking pH levels for a pistogramma fish.
It feels like he's treating the fish tank like another programming language.
Well, you've hit on the core mechanism of his entire worldview there. It is all pattern recognition, and it is all systems thinking. The software plumber ethos isn't restricted to a computer monitor.
A plumber looks at a system, identifies where the flow is broken, applies a constraint, and optimizes it.
Yes. And Aang applies that exact same troubleshooting mindset to biology.
The natural world is just another open source project to him.
Think about the fish cave. A pistogramma is a type of dwarf cichlid. They are notorious for needing highly specific environments to spawn. If the water's pH is off by a fraction, or if the physical layout of their environment doesn't offer the right security, they just won't breed.
So what does he do?
He maintains a spawn log. He checks the pH, the temperature, the nitrate levels. If the fish don't breed, that's a bug in the code. He adjusts the water parameter and reruns the simulation.
That makes perfect sense.
Right. And when he designs a physical cave for the tank, he is literally constructing an environmental constraint to produce a desired outcome. It operates on the exact same logic as putting an end-of-line constraint on a Chinese text string to make the Haskell parser work correctly.
And the gardening works the exact same way. The Brazilian spinach and white sesame soil, he's tracking the inputs like light, nutrients, and soil composition, and he's logging the outputs like growth rate and leaf color.
If a plant wilts, he tweaks a variable and tries again.
He's not doing 50 different things, he's doing one thing. Systems optimization applied to 50 different environments.
The discipline of documenting 2 posts a day is actually a mechanism for forcing himself to constantly observe the systems around him, both digital and physical, and to articulate how they function. It's like a unified theory of tinkering. By writing it down, he makes the hidden mechanics of his daily life visible and adjustable.
To briefly recap this journey for you listening today, we started by looking at a tiny, missing piece of code. an end-of-line check for a Chinese text string in a highly logical programming language.
Just a drop of pond water.
Just a drop. And by zooming out, we uncovered a 15-year, multidisciplinary worldview of a relentless learner. A true software plumber who treats both the digital code on his screen and the natural world in his garden as complex systems to be nurtured, debugged, and understood.
It really shows that if you have the right framework, there's no such thing as a boring problem. A parsing error or a wilting spinach leaf are both just puzzles waiting for the right constraint. Everything is connected through the underlying logic of systems.
Which brings us back to that microscope slide from the very beginning. The boundary of that drop isn't a limitation. It's the constraint that makes the whole universe inside it visible.
That's a great way to look at it.
And I want to leave you with a final, provocative challenge to mull over as you go about your day. Think about your own daily tasks, your own hobbies, the things you brush past. What if you started your own private bug tracker or your own spawn log for the small things you learn each day?
Just tracking the micro progress.
Exactly. You don't have to publish it to the internet twice a day like Aang does. But what if you adopted that plumber's mindset? How might looking for the missing boundaries, the missing constraints that can actually simplify and optimize your routines, change the way you operate tomorrow?
It's worth considering.
What hidden systems in your life are just waiting for a little bit of plumbing?